Chris. You sure you want to stay? You can back to sleep or something. Rest. Eating a sandwich, Kiefer? Interesting. Well, this is Thanksgiving week. Looking forward to it. Family getting together. No, no more than 10 people, right? That's what Akumo says. But they don't have a way to enforce it. I don't think they're gonna enforce it. They can't enforce it. How do they know how many people in your house? So Kiefer, you use the palm for the Marvin for your project, Kiefer? I saw you had a palm file on your project.
What, like Maven?
Yeah.
Oh, that was just for 1 sec. So I tried to do the graph using I think JGraph. So I tried to import it using a Maven, but I don't think it's actually made it into like the final GUI or anything like that.
I could run your program. Looks good.
Thanks.
Tim did a good job. Hey Tim, how's it going? What's wrong with your webcam?
Hello, eating a sandwich.
What?
I'm eating a sandwich.
Oh, okay. All right.
Thank you. Thanks. Good to hear. Yeah.
Yeah. You did the job. Come a long way. Couple of things. I was reading your project, reading the code. It's very, very diverse. It's very hard for me to figure out because occasionally the program crashes. It's very hard for me to figure out what is actually working, what is not working. I don't want to not give you the credit for something that actually works, or at least from your point of view. So I think what I need to do is I would like to set a time either with the whole class. Say we take a day, so all of us will get together like in here, and we look over each person's project, or we can just have like a individual meetings, like online like this. So we need roughly like 10 minutes. So this way I can ask you questions. I can, you can go over your project with me. So this way I know, what you meant by doing certain things. Another reason I want to do that is I can see the obvious issues, like people been doing poorly or been doing poorly in the past, all of a sudden doing really, really well. And isn't the project is not done anyway we talked about in class, has nothing to do with what we talked about. So I just don't know what's going on. So I would like the person to explain to me in detail and prove to me that you actually did it. Okay, if you actually did it, even though it's not done the way I want to do, I will still give you credit for it, but I just don't want you get a credit for paying someone else did it for you. Okay, because that is a good sign usually. You pay someone else to do it for you when you been always doing poorly, and then all of a sudden you turn out a project that works, but it's nothing to do with what we want. Okay, without all those things we talked about. So I think that's something very important for me to figure out. Um, so, but we are tight on time. If we spend a class going over this, it could be a problem. Maybe I think it's better if we do individually. So this way, some of you will not be embarrassed in front of other people, right? So, but on the other hand, somebody cannot be so much showing off in front of other people as well. Okay, so I think maybe a good idea just have individual meetings for 10 minutes or so for each one of you. We could be any time. I think this week we have a few bad weather days, or even early next week is fine. I will give you, if that's okay with you, I will give you a few days, say Friday or whatever, day and the certain time slots. And if you are available, you could just email me and then set up a time so I can go over with you with the code. Um, I don't know if that's okay with you, right? Otherwise, I would just have to go over with the whole class. And I think it's a little bit harder to do because we have so many people. And if each person gets 10 minutes, we're talking about a couple, at least 2-3 hours to go over. Okay, so that might be a problem. Okay, so if it's okay with you, I will send you a schedule. So you guys can email me and tell me when's good time for you. As long as there's no conflict, no other people pick the same time, then you'll be fine. Or you can give me a little bit range, okay, say between 2 and 4, okay, or between 2 and 3, rather than just 210. Has to be 210, then that's harder in case someone else picked up 210, right? So I think maybe that's something we can do. Right, so this way I give you all the credit you deserve. Okay, so this way I won't miss anything. Okay, and then you feel comfortable talking because no one else is there to make you feel uncomfortable. Is that okay, guys? Yeah, just 10 minutes. I want to look at your code, go over the code with you, and I see problems I would like to point it out to you. Rather than I will read the code and then try to make a comment by writing out. Is long writing sometimes. Okay. I think that's fine then if you agree. So I'm going to send you a schedule, and then hopefully we can get it done this week. I downloaded your project. Some of you use IntelliJ, so I have to actually recode it, copy over the actual Java files to put into Eclipse. And some of you use Java 8 still. So I think you should all go to at least 14, 15, right? Or 13 at least. Don't do 8. 8 is old. Okay, there's a lot of new things after 8. So you probably should move on, okay? Don't do 8. Because when I try to import 8, I can't really run it. I have to reconfigure to run with my 15, Java 15. Okay, so I think that's something you need to do. Now, when we meet, right, say we meet at 2:10, say, okay, you should have your computer, you should have the program loaded up. So this way, I have your program loaded on my computer as well. So this way we can go with the code, we can run the program, and I can look at your screen, you can look at my screen. So I can ask you questions and then you can ask me questions. So rather than, we meet at 2:10 and then wait for you for 20 minutes before you set up your computer, or you don't have a computer, then it's not going to be helpful, right? Good. Yeah. So I try to make it flexible. This week is just 2-day week, just Monday, Tuesday. So I think I'm going to have some time. Even evenings okay, right? So so I can be flexible, in other words. All right. Okay. Now the other thing I think I should apologize, that is, some of you used tree set, right? And some of you still, like, another example is we talked about the number of users, number of trails are unknown, right? So we cannot really use hashing, right? Because hashing is based on arrays, right? And so to use hashing, you have to know how big the hash table is beforehand. So you have to have a limit, a cap, how many users you can have or how many trails you can have. But we said you cannot have that. Then some of you guys have programs developed using hash map, okay, which is something we said we shouldn't use. But some people used it anyway. So that made me think, you didn't do it because we talked about it in class. Okay, now if you use trees, right, you could have used tree map, right, and you also could use the tree set, right. Now tree map or tree set. Tree map will give you a big O of log n, right? We know that big O log n, because there's always a key value pair, right? So if you give me a key, I can search the whole tree rather quickly to find the particular key in the tree, right? Because the tree is built based on the key values, right? The left child is smaller than the parent, and then right child is equal to or greater than the parent, right? So that will give you a very good big O of log n, right? You understand that? Okay, but the condition, of course, is you have to know the key, right? You have to know the key. So when you use a log on, right, a log in, the user putting a username, and you happen to use the username as the key, that will be good because username needs to be unique anyway, right? We know username has to be unique anyway, right? So password does not have to be this unique. People can use the same password, but username has to be. Okay, so that will be a great application, right? Use a username as a key and the user object, which is a more profile object, as the value. Okay, that will definitely give you a big O of log n, correct? Yes? Okay. Now, the problem is with tree set. Okay, I didn't talk about this clear enough, I think. Tree set, if you know what object you're looking for, okay, in a tree set, okay, if you already know the object, you just wonder if it's there or not. Okay, say you have an object that's this username, this password, so on and so forth. You know exactly what it is. Okay, and you try to find such object, okay, in the tree. But really, you're not really trying to find the object. You just want to see if the object is there or not. It is different. It's because you already have the object. Okay, when you look for the object, you already have the object. You just want to wonder if that tree contains the same object. Okay, so if that's the case, you get a log n, right? You get a log n because the tree for a tree set is based on a key value as well, but the key value is built in. Okay, could it be the say the trails? I see many of you use trails, right? Could it be trail name? Okay, but that does not have to be unique though, right? It's not like a tree map. Tree map, the key has to be unique. You understand? But a tree set, the key does not have to be unique because in a binary search tree, if the key is the same is allowed as long as you put on the right side, right, as a right child, right? So the bottom line is if you know what object you're looking for, then you just want to see if the tree contains the object or not, then you can use a method called contains. I don't know if you remember that. Just the tree dot contains, right? That is log n. Okay, in terms of finding, that's log n. That will return true or false. Okay, that will return the true or false. But if you don't know the object, all you know is just the trail name. All you know is trail name, but you have nothing else, because multiple objects can have the same trail name, right? So you cannot find the object contains that trail name quickly. Because in order to find that trail with the trail name you specify, really it has to go through all the object to see which one contains the trail name you're looking for. Okay, so it really depends on. Let me actually give me a second. Let me actually show you the point. I think it's important, but I didn't make it clear enough. I thought you could have figured out, but it's okay. So you're not gonna lose credit for that, but I just want you to know it, okay? Because I think it's important. Let me load up my computer, my Eclipse, then I will show you what I mean. Then probably will feel easy to understand. Okay, hold on. Let me just start my Eclipse, and then I wrote a quick program to demonstrate that. Okay, demonstrate that point. Give me 1 second. And okay, I'm going to this. When I read the code, then I realized that is a potential problem. Okay, hold on. So I wrote some code and tried to explain to see if I make this point. Okay. Just rename it. Okay. All right, so let me present to my screen. So I think it's so important. I don't want you make a mistake here just for the future. Okay. All right. So I wrote a quick program here, and it has a just class called a book. You can think of it as a trail, okay, or anything, okay. It has a bunch of instance variables. You can see. Is it too small for you, or is it okay? Is it okay? Can you see it? Yeah. Okay. So I wrote a simple class called a book, and it has a title, author, ISBN, price, right? And I cannot just put them into a tree. I have to tell Java how you're going to compare the different book objects, right? Because potentially you can compare the title alphabetically, which one's smaller, which one bigger, or you can do the author, you can do ISBN number, you can do a price, right? So there are many different ways you can build a tree depending on which instance variable you use to evaluate the size of the object, right? So I had to implement a comparable, okay? Comparable. Since I'm comparing books, I use a generic say book, okay? So because of this interface, I have to implement this method called compare to, right? So by writing the compare to, I'm specifying I'm going to really build a tree based on title. Okay, so title string, the string of the title determines whether the object is smaller or bigger, or should be the left child or right child. You got it? So you have to have such a thing in order to build a tree. Okay, to tell which one's bigger, which one's smaller, right? Otherwise, Java has no idea how to build a tree because potentially there's so many different ways. Okay, now I also we talked about this hash code and the equals, right? Okay, you remember this? We talked about this. This is called override equals method. So you override the default equals method, right? The default equals method compares the memory address. I hope you remember that, right? And if you implement your own, then you can have your own dot equals method to compare the content of objects. Okay, it's just like a string. Okay, dot equals contains the content, equals contains the memory address, right? But unless you override it, equals and the dot equals is the same thing. By default, just compare the memory address, right? So I purposefully implement the equals method and hash code method. So this way, I can do dot equals method to compare two objects if they're the same content or not, right? Okay, the point I want to make is when you do say tree set or tree map, right? The criteria of comparison is based on compare to, not based on this dot equals method. So without dot equals is not going to change anything. Okay, it's not based on dot equals. Instead, it's based on compare to. So that's what you need to have. You must have. Compare to is what you must have. Okay, all right. So this is easy enough. So let's take a look at the demo program. I create a bunch of books. You can see, right? And they have different titles. You see, it's all random, not in any particular order. I have ISBN also, just random, not in any particular order. And I create another book, which is really just another random book. Okay. Now I'm going to create a tree set. Okay, that's a tree set, right? And I specify the tree set is going to be used to store books, right? Okay, just like you guys will use the trails, okay? And now I'm adding all the books object into the tree set. Okay, so now by the end of this, a tree is built, okay, based on ISBN number, because that's what we wanted, right? That's what we wanted. We specified here. This means it's going to be ordered by the natural order. Natural order means alphabetic order. If this title is A and this is B, it should return a negative value because this is smaller than this one. Okay, if the same, it will return 0. If this one is actually bigger, say this is B, this is A, same case, then you'll return a positive value, right? So that anything like that, we call the natural order. So basically, that's what we decided to do. Okay, by adding all the objects into the tree set, okay, we're using the ISBN number to build the tree. Okay, because we use the API, so tree is guaranteed to be balanced. Okay, it's balanced, so you can potentially get that big O of log n. Okay, because it's balanced, right? Okay, that's crucial. All right, now if you just want to do something like this to search, this is a search, right? This is a search. No, I'm sorry, I meant this one. Okay, so you see, I want to search this, and I'm using I build a new object. You see, I'm searching for this object. Okay, I'm searching for this object, and this object has BBB. Okay, and there's a BBB here, and that's the only thing the contains are looking for, because we specify, again, that's what we specify how we compare them, right? Because that's the key. The title is the key, is used to build the tree. So if you just want to find a book that contains a BBB as ISBN, okay, and that will give you a big O of log n, because you specify the key. Okay, that give you log n. So contains will give you log n. Okay, but if I want to do this, I cannot do it because the tree is based on the ISBN, not based on the name. Okay, you will say false. There's no such object. Okay, you will say false. Because again, the object is identified really by the ISBN, not by the name or anything else. Okay, so this will give you a true, because contains returns a Boolean, only gives a true or false, either true or false. So it will give you true, you see, purely because this is has the same ISBN number, because that's really the only thing it compares. Okay, now of course you could look for another book, say this book B5, say B5 is there. You know B5 is there, right? So you could say is B5 there? Okay, is B5 there? Right? So I'm just say is B5 there? Now B5 of course has the this okay. It has that ISBN number. You see that? Okay, so it again it gives you a big O of log n. It gives you a really quick one, right? Okay, now also if you have a new one you want to add to your to the tree, that's right. If you want to add it, and that gives you log n as well. Okay, you just organize things based on the ISBN, and we'll insert it for you and give you a speed of log n. So when you want to remove, in other words, you have object with this particular ISBN you want to remove, is also log n. So three things are log n. Add is log n. Okay, remove is log n. Contains is log n. Okay. That's it. Okay. Now, if you, on the other hand, if you have a if you have a name, say the tree is based on ISBN, right? Say that's how we build the tree, right? ISBN. Now we decide we want to find a book with a particular title, say M, which is not the key. Don't forget that. That's not the key. ISBN is the key. M is not the title. Is not the key. It's like a trail name is not the key, right? And also you want to find a author name is John Doe or whatever name you want. Okay, so what happened is you could do many different things. Let's disable that. So one thing you can do is you create a iterator. Okay, now as soon as you see iterator, that means something. Okay, that means you're gonna go through the tree one at a time. You go through all the object in your tree, one object at a time. As soon as you see that, you know it's not gonna be log n. Because you have to go through every single object to see if there's such a name you're looking for, such an author you're looking for. So it's not going to be log n. Okay, so the reason I wrote this is because it shows that you have a while loop. The while loop will go through the iterator as long as it has a next. It's going to try to open the object and see if it has that name, has that author's name, or the title or the author's name. Okay, so that tells you that is actually, this algorithm is actually n. Yes, that's actually n. Okay, so I just want you to know, okay, if you did this, it's actually tricky because one of the requirement I ask you is the user could search by name, search by length of the trail, search by the difficulty level, so on and so forth, right? Okay, unless you build a multiple key key value pair or tree maps, if you use a tree sets, it's actually, if you're just looking for a particular item, it's actually very hard. It's not that easy. It's actually log n. It's n, I'm sorry. It's actually n. It's not log n. Okay, if you want to looking for name and looking for length and difficulty levels from the same tree set, it's going to be actually n. It's not log n. Okay, now so in order to demonstrate to that, right? So I will take the iterator. I will go through each one of them. You see, dot next, right? So from the first one to the last one. Okay, and I'm going to actually display every book as it goes through the iteration. Okay, and I'm going to disable this for now. Just want to see what the iterator does. You will see what the iterator does is going to go from the smallest key to the largest key, one at a time. That's n, right? So look, does anything? Let me turn off this for the moment. Okay, so when I'm going to run this, watch. Okay, it's going to display all the books purely based on, you see this? Oh, what happened? When I changed the ISBN, maybe I changed the wrong file. That's actually based on the title. Did I do title? I did title, actually. My bad. I think I did the title, right? Yeah, it is title. So that's why it's sorted by title. Okay, so when you go through the iteration using the iterator, it goes from the smallest title to the largest title. You see this? Okay, it does go through every single one of the object. It's not going to just go down one line, one family from the root to the well, one particular branch. It actually goes through every single object. So that is n. That is n. Okay, so what we are trying to search in this case, if we know the name or we know the author's name or whatever, or title, then I can just take each of the object and open it up, look at the title and look at the author name and make a comparison. So obviously that is not going to make it as faster. You still have to go through every single one of the objects. So when we run it like this, you will see the two M's, you see? That's the one actually found. Okay, it does go through every one of them. Okay, so that again is n, not log n. So since this demonstrate to you, this line demonstrated to you that every single object is actually visited. So that is already n. Now, if I do this, you found the one you're looking for, but the big O is n, is not log n. Why? Because you don't know the whole object. You don't have the key. All you have is a title or the author or price, they're not keys. So you can't really do it quickly. Okay, so if you want to implement it like this, that's fine. That's fine. It's going to be slower than login. That's all. It's going to be n. So this is a little bit tricky at the job interviews because they say, hey, this is a tree set. It's a tree. When you do search, it should be login, right? Because if you memorize this without actually look at the code, actually do it yourself, it's easy to think, since I have a tree set, it's based on tree, of course I get login. But in this case, it's not like, it's actually not true. Only when you do contains. If you know the object or you know the key, fine, you get a login. Of course, add and remove, you get a login. But if you just know partially of the object, not the key, then it's going to be n. You got it? Okay, so that's one implementation. That just use an iterator, and I'm going to disable this, and I could also do things like this. Okay, so there's another way in the set has an API, has a method called a subset. Subset allows you to look for something, but again, you have to know the title. Okay, you have to have the title in there. The title, the book does not have to be the original book, but it has to have the same title. So because I use this constructor, you see, right? So I had a overloaded constructor. You see, I wrote another constructor there to create the possibility to create a book based on the title only. Okay, so when I did that, just if I know the title, knows the key, I can get that login, right? I can get a login. Okay, so but in this case, though, you're doing a subset. You're going through a whole range of books. This is the beginning of the range. All the books start with a C, and all the books ends with an N, and everything in between, alphabetically. Okay, and true means C is included. This true means N is included. So I get a subset of all the books that fit this requirement. That also is N. Okay, now I'm going to display this for you. Okay, watch. I'm going to display this. It will tell you all these things matched is in here. Okay, so that's a C, M, N, that's all included. But if I got rid of the two trues, okay, if I get rid of the two trues, just the beginning and the end, and will just give me the one in between, not inclusive. Okay, we'll give you the C and M. Hold on, why I have a C? I have a C, I got rid of a C, B subset. I don't have a true. It should give me M. You should not give me C unless I show the C somewhere else. I don't think so. What did I remember wrong? This is C. That's weird. Did I get a C somewhere else? That's the subset. That's correct. Did I get another print somewhere? I don't have another print. True and true. So that means I get both C and N. C and N. Interesting. Maybe I remembered wrong. One book, title is C, another one is N, and that should mean just between the two. Obviously, it's not right. So I think I remember wrong then. This by default, the starting is always included. Okay. All right. But that or still, you're not getting a login. Okay, this I already said. If you know B3, that is login. Okay, now this one. Okay, if you go through the set one at a time, okay, you just check the title individually. If you do this way, you also get a N. Okay, if you just do this, let me disable this. Okay, just look at this code. I have a set, had all the books in there, and then I take each book. Okay, I get its title and compare with the title I'm looking for. Okay, then print out this object. If I do this way, that's also N, because that is actually a for loop. That is a for loop. That give you also N. Okay, so there are many ways you can actually implement a search, depending on what you have, what you know. Okay, sometimes you can get an N, sometimes you get a log N, depending on how you implement it. So there are different ways to implement. This is just another way. This is a kind of natural. You know, you have a book, title is M. You will say, oh, I'm going to go through the whole set and just see which one has the title of M. If you do this way, it's actually N. It's not the log N. Okay, but if you do contains, that is log N. Okay. Okay, finally, I'm going to go through this for you. This I found many of you use this, right? You see, I have a tree set, right? I stream it, right? Stream it. So all that means is to take the whole tree, okay, and you put all the object into a stream. So every single object is fed to the filter one at a time. That already tells you that's N, right? That already tells you that. So every single object in the set is streamed into a series of objects and they get passed to the filter one at a time. So each book, you're going to compare that book with the M, the title of M. You see that? That's the predicate, remember that? Okay, so if you find a match that equals to 0, that means you found a match, right? You found a match. And when you found a match, you're going to collect it into a set, eventually into a set. So we do have to go through every single object in the set, in the tree set, in order for this to complete. Okay, again, it's easy to write, so used widely, but if that's what you use, then that is N, because the way you did it is streamed. Easy to write, easy to understand, but you get an N. Okay, as long as you understand it, that's fine. You don't care the difference. If you say the number of trails in thousands and not in millions or hundreds of millions, then you can accept that N. That's fine. That's fine. Especially when you have the requirement, you want to be looking for searched by name, by title, by author, by the type of the trails. You want to do all kinds of research, then you have no choice. You have to use a predicate to do it. Unless you build all kinds of trees and each one use one as a key. Right? So in general, this is just some sacrifice you have to have. You have to accept, just the way since that's how you want to search it, right? And I look at some of you guys had the data imported to your app, okay? And so when people search, when I run your program search, it's actually pretty fast. So you get an idea. So anyway, this is something I think you can understand, but I just want to emphasize it's not just because it's a tree set, automatically everything is log n. That's not true. It's really depending on how you implement it. Okay, but for sure, if you have when you do add method, remove method, and also contains method, definitely those are login. Okay, and if you do stream, okay, you're already accepting this as n, because you're going to filter every single object go through based on the whatever predicate you want. Okay, in this case, the predicate happens to be the title m. Okay, but it could be anything else. So this gives you flexibility to search in different ways, but does not give you that login. Instead, you end up with that. Okay, so whatever you did, that's fine. But again, I just thought it's good to go over with you, make sure you understand this. There's some subtle differences here. You can tell by looking at the code. When you have a for loop in there, when you have a string, you know that got the end. Okay, don't automatically accept this is a login because it's a tree. All right, good. Yes. All right. So, do you have any questions on this? No. Okay. When you don't have questions, then today we're going to talk about another design pattern, because the last time we talked about MVC, remember, model view controller, and so that we finished that. Okay. I don't think you had any questions that last week. So today we're going to talk about another design pattern, which is quite interesting. It's called observer design pattern. Observer design pattern. Okay. I'm going to first of all, because we're talking about design patterns uses a lot of interfaces than inheritance. Okay, let me close all this. All right, let me close all this, and let me see. So I'm going to do this time is called observer design pattern. Okay, observer design pattern. So you can see I used 15.1. Okay. Now I'm gonna write. Let me write a quick text file here. Okay, so we will see the whole time when we talk about design pattern. What's important is what we have a famous saying that is we favor composition over inheritance. Okay, in other words, whenever we can get away with a composition, okay, composition, you know, is something called a has a relationship. Remember that? Has a relationship. So the library has books, right? Has a set of books. That's called a has something. Okay, and inheritance is something. Okay, so composition is has a relationship, has a relationship. And over inheritance is called is a relationship. Okay, so is, you know, is a, the reason is because inheritance forces you to get everything the parent class has. And you cannot say no. As long as it's not private, you automatically get it. And because of it, it gets you less flexibility. And the coupling is very tight. And we want to have loose coupling. So when we make a change, it won't affect, won't have a big ripple effect Okay, so that is a very, very important principle called favor composition over inheritance. So if we can get away with the composition, we should not use inheritance. Okay, now when we talk about composition, we can have things like inheritance, because inheritance gives you something without forcing you to have it a certain way. Okay, it gives you some methods you can implement, you can override. It doesn't impose any instance variables onto you. Okay, so you can have a lot more flexibility. Now, so throughout the whole time, we're talking about design patterns. We will see the importance of it. Okay, so now let me explain to you what is I observe design pattern, and I would like you to do some homework for this segment, design pattern, because you need to prepare you for the final exam. Okay, so I'm going to give you some homework as we talk about um, design patterns, and I would like you to kind of use design patterns we learned as we go, and integrate them into new assignments, new projects. Not a really big project, just small assignment questions. Okay, we're talking about a model view controller. So from this point on, whenever you do some applications, if it has a view, has a GUI component, you should use model view controller. Okay, you should not mix them anymore, in other words. Okay, from this point on, since we finished talking about model view controller. Now, let me clean this a little bit, and then I can talk about I don't know what this. Okay, say let me make this bigger. Say you need to develop some application, right? And the application has something called data object. You will hear this kind of terminology. Okay, data object is meant to be used to store data. Okay, because object has instance variables, so it stores the data, right? And the data gets collected from different places, right? Say the data come from these different places. In this case, maybe there is a temperature sensor that sends the data to the data object, and then there is a humidity sensor, right? And there are some other sensors that sent to the data object. Now the data object gets updated by those sensors. They get new data all the time in real time. Okay. Now your job is to develop a program that will display the current condition. So this is the data object we call weather station. Okay, the weather station collects the data from sensors, and whenever there's a new data, then the sensor gets new data. It sends data to the data object, and data object will provide the data to displays, to views. One's got the current condition, another one shows weather statistics, stats. I'm just going to say stats. Okay, another one says a forecast. So forecast. So that forecast the weather. Okay, so there are three different views. Okay, so once the data object gets updated by the sensor, then the data object should notify the three views, tell them that there are new updates. The new updates. Okay, so that's the job. That's the job. Okay, that's the job. Okay, now you can probably write such a program already. Okay, you can write such a program already, and I can actually show you how that's done. Okay, so we can write such a program already. You can understand it easily. So I'm going to write a package P1. Okay, so I'm going to call it the weather station. Okay. So over here, I'm going to have a class. I'm going to call that a class weather data. Okay. So that's the weather station is collect the data, right? So weather data, and let me make this bigger. I think make it 12. Now I need some instance variables, of course, the temperature, the humidity, and all those. So I'm going to say instance variables. So you know that. Now, the important thing is you want to have a method called a measurements changed. Okay, so that's the method. So whenever there's a measurement change, that means make it public. Okay, so whenever the measurement, say humidity, temperature, when this gets changed, or pressure, right, gets changed, then you can notify the different displays. So I have things like current condition display. Okay, so that is an object, then update it, update the view, okay? And then you have another one similar to this, another one similar to this. So this is going to call the statistics display. Statistics display. Okay, so make it longer. Statistics display. And then finally, I have another one. It's called a forecast display. Forecast display. Okay, so it has three objects. Okay, one is the current condition display, and a statistic display, and a forecast display. And then just you want the method. This one is easy to understand. So each of the display has an update method. So we know we need an interface for that. So we force all the views to have a update method. Okay, you force them to have update method. And now, of course, you're gonna somehow get the data from the sensors, right? Then you update them. Okay, so it seems to be a reasonable solution. Whenever you have a new data, you can run the measurements change, and then you update the three views, right? Okay, so that'll work. It will work. However, though, there is a problem. The problem is, what if I want to add a new display? If I want a new display, a new kind of display, then that means I have to go back to the measurement change method to add a new display. Say I want a new display somehow. Okay. So now, if you want to do that, you're gonna have to open this weather data or weather station, and you have to change this method, and that violates the principle called open closed principle. You see that? So after all, this is not the best solution. Okay, that's not the best solution. So instead, you want something more like this. You want something. What we say something like this. So we can have something similar to we have a again, this time is a data object. Okay, so data object. In fact, that's the data gets stored, right? Now, you would like to have such a mechanism. So every display, if you want to add it, you just have to register with this data object. So data object has the capability to allow potential different kinds of displays to register, to sign on. Okay, so data object keeps track of who is dependent on the data object. So these are called dependents. Dependents. Okay, so they're dependent on the data object. Okay, and they just notify the data object to say, hey, I'm interested in this. If there's a new change, let me know. And the data object is such a robust design. So whenever you have anything new, new display, just let the data object know, and then data object just knows and then let you know whenever there's a new update. There's no need to actually hard code the display in there. There's no need to hard code display. Okay, so that is similar to a situation like, say you're looking for a job, you call the headhunter, you say, hey, I'm looking for a Java job. The headhunters are great. Let me write down your contact information, right? So you registered by doing this, you register with the headhunter, right? And then another person may do the same, and the headhunter will just record that contact again. And the third person may want to do the same thing. So the headhunter collects a whole bunch of contacts of the people who potentially looking for a Java job, right? Okay. Now, if you found a job already, you can tell headhunter that I'm no longer interested in the Java job. I got my job already. So the headhunter just remove you from the list. Now, whenever there is a job coming up, the headhunter happen to run across, then the headhunter will just notify everybody on the list, say, hey, I do have a Java job came up, and then whoever interested can apply. So it just notify everybody on the list. Okay, so that's the idea. That's the idea. Okay, so that's also something we used to do. Say whenever we run like a debug, remember the debug? We click on the menu item. It's not just one thing gets invoked. There's a lot of things gets invoked. The whole view looks very different when you do that. When you go debug, you set up some kind of a say, I don't know, this is not a complete program. You toggle breakpoint, and then when you run debug, it actually changes a lot of things. For example, you changes the view, even changes the debug. It doesn't change this time because it's not a completed program. I'm running something else. So so one action causes one change, one single change causes a lot of different ripple effect across the board. That's called observer design pattern. Okay, so now we can do it more generally. We have something like this. Okay, generally, the data object that contains data we actually call the subject. Okay, we call that subject. That's where the data is stored, and then that's the other objects are watching. So everybody else are called observers. So these are observer 1, observer 2, observer 3. Okay, so what they need to do is, if they want to observe the subject, they just register with the subject. Okay, so this register with the subject. So the subject will have a data structure that holds all these observers object as a reference variable. Okay, it just holds all the observers. So it knows who the observers are. Okay, and each observer is implementing an interface that has update. Okay, so each observer has update method. Okay, So now, whenever there's a change on the subject has a data structure holds all the observers, right? Then we'll go through each of those observer objects and run the update method to update that observer. That's where the trick is. Okay, so every observer will register subject. Subject will has a data structure to hold all these, say the tree or whatever, holds all these observers. So whenever there's a change, new data come in, it needs to notify everybody. We just cycle through the data structure, say array or array list or whatever, tree list or a linked list, whatever, and then just run the update method for each one. And then that will update each view based on its own update method. Okay, so that's the right way to do it. Okay, so now I'm going to actually implement this way, and you will see how interesting it is. Okay, so let me see. I have a program. Let me see. I can. Okay, I'm going to start. I'm going to write this program. I can kill this for now. Okay, so I want to ask you to implement it using MVC and observer design pattern to do such a application. Okay, so let me write a actual example. Say P2. We're going to call the grades observer. Grades observer. So I'm using a student as an example. Let me. So this is not a good implementation, okay? Because you cannot really easily add a new views, a new display, okay? So let me do the P2. Okay, now I'm going to do the object first. Okay, do the subject first. Subject. So I'm going to call this class. I'm going to call it student. I think I'm going to call it, yeah, student. Okay, so student. Student has a GPA or grades. Okay, so whenever there's a change, there's a whole bunch of observers need to be notified. So at the end of the semester, when I post your grades, not only you be notified, the college registrar notified, transcript office gets notified. So that's a typical example of observer. So one change, many observers are notified. Okay, so I'm going to have this class called a student. Okay, and let me close this. And the student has a name, so private string name, the student name, private double GPA. So these are GPA change, then multiple observers will be notified, in other words. Or if it's a name change, you can do that too. If it's a name change, a lot of things will be notified. Okay, now here's the constructor, public student, and the student gets a string name and double GPA. Okay, so we just say this dot name equals name, and this dot GPA equals GPA. So that is just a regular class, right? A regular constructor. But now don't forget that the student is the subject, right? So it has to be able to store all the observers. So in case there's any change, you can notify everyone, right? So it has to have a data structure to hold all the potential, not potential, actual observers. That's something new. That's new. So in other words, we must have a data structure to hold the observer. So you see private, I'm just make it easy, say array list. Array list. Okay. And there are observer. Observer. Okay. Now, what is observer? Observer could be a student. Okay. When your GPA changed, you are notified that the GPA is different now. But could it be the school where you want to transfer to? Okay. Could it be the transcript office? Or could it be some other offices? Okay. Whether they're going to send you a letter, say you're on Dean's list or something. Okay. So those are potential observers, but they are very diverse. Okay. Some just like an address, some is some office, some is some person. Very different. So that's why I need to have a general category for all the observers. Okay, the best way to do that is to have an interface. So whoever implements that interface is an observer. Okay, so in other words, I need to, in order for this to work, I need to create a new interface. I'm going to call that observer interface. Okay, observer interface. Now, then the observer interface just need to have a couple methods. Okay, really the most important one is the update. Okay, what to do if there's a new change, right? So you require all the observer to have a method, and this method is called void update. Okay, now update is sending its name and is sending a GPA. Because of it, whoever implements observer interface belongs to can be put into array list, regardless who they are. Maybe the transcript office, maybe a 4-year school, maybe graduate school, maybe anything, right? So now all you need is I just need a array list to hold that. Okay. Now I'm going to call this observer list. So observer list. Okay. Now, of course, I need to create the observer list. Observer list and equals new array list. Sorry, array list. And there you go. So let me import array list. So now I have all the mechanism I need. Okay, because potentially I allow people to join, to notify me. So I just put those observers onto the list. So whenever there's a change, I will notify everybody on the list. End of the story. Okay. Okay. So we have that, and then we're gonna have the getter setters, like usual. Source. Okay. So in case we change, right? Okay. Now we don't want to change those, so we don't need to set the change the observer list. Now, I do want to have something else. Okay, I want to allow observers to register, right? Basically, add the the observer onto the array list. So here is the method: public void register. Okay, so who want to register? Just say the observer. You give the observer, then you can register. Okay, now all you need to do is observer list add. Oh, okay. See, this allow you to add a observer into the observer list. So this way later you can notify. Okay, so there's a method called register, and there's another method called unregister that just say you're no longer interested in something information. So you found a job already. You tell the headhunter that remove me from your list, and don't notify me because I'm not looking for a job anymore. Okay, so it's a public void unregister. Register, and then when you unregister, you just put the name as well, observer as well. Okay, to unregister, all you really need to know is observer. First of all, you get the index. So index where that's located. Index equals observer list dot index of O. So you find out where O is located on the array list. Okay, you find it, then you remove it. Remove it observer list dot remove. Okay, index. So you move it, and so you just want for demonstration purpose. I'm going to okay. I'm going to say things like observer plus index plus 1 because index starts with 0. So I don't want to call your index your observer 0. There's no observer 0, so observer 1 instead. Okay, was removed. Okay, so that's the unregistered. And then finally, you just have a mechanism to notify everyone on the list. Okay, so all you have to do is public, okay, void notify observers. Okay, so we're gonna you just say for loop. You say observer. Oh, observer list. So you're going to go cycle through the whole list, and then all you have to do is o.update. Update with your the name and new name or new data, whatever is new, or the current state. Okay, just update it. So that's how you do it. That's really what the subject needs to do. Allows observer to register, which basically is add the observer onto the observer list, and allow the observer to unregister, basically remove from it. And then finally, it has a mechanism to notify everybody, basically go through that whole array list to run update on each object. Okay, so that's why the update needs to be in an interface that guarantees everybody has that method. Whoever implements observer must have such a method. Okay, called update, right? Now, this will just work. This will work, okay? But I want to add that these three methods are crucial. That's what really important. That's what is really important, right? You allow people to register, unregister, to notify, right? Because of it. So we usually will actually do something, write another interface, and we call it observable. Okay, observable interface. That means this is a subject. Whenever you see something observable, means it can be observed by observers. Okay, so by having observable, then you can create an interface, and it's called observable. And then you can have those three unimplemented methods. One is called void register. Register observer O. One is unregistered observer O. Okay. Another one is update observers. Update observers. Yeah, that's it. So So you are actually making this more explicit. Okay, you'll tell. So from this point on, whoever wants to be observed, whoever wants to be observed, just needs to implement this interface. Then you will have to implement those 3 methods, which are necessary. Okay, so let's go back to here to the student, and these are just unimplemented method. I think unregistered. So this is, I'm going to call this add override, right? And this should be add override and add override. Okay, so let's see. Apparently there's a observable. Did I spell it wrong? Observable. That's okay. Let me save this. Why have such a file? Oh, that I don't care. That's just this file. Okay, so you just remember this. I don't really need this. Okay, favor composition over inheritance. That's why I'm using. Can I delete this? Don't save. Okay, so notify observers. Did I write it wrong? Notify observers. Observable. This and notify observers, not notify observers. Okay, I'm going to call notify observers. Save this. Now that should be okay. So I actually implement that interface. Okay, it's called observable. Okay, so now from this point on, whoever wants to be observed, just implement observable, and then correspondingly implement those 3 methods, and that's it. That's it. Okay. Now we also did the interface for observer, which is good. Now here is what we're going to do. Okay. Now whenever there's a change of a GPA, not only we're going to change GPA, but also we're going to run this method, notify observers. Notify observers. That's the trick. So whenever there's a new set GPA, whenever you change GPA, you're going to notify the observers. Okay. So that is if you want to change notify observers because your name change, you can do this too. So whenever there's a new name, okay, there's a new name, somebody changes the name, you can notify observer as well if you want, or just do the GPA without name or vice versa. You can do whatever you want. Okay. The point is you could notify based on whatever reason. All right. Now we're finally at the stage to implement the observer class. Okay, so we're going to create a new class called observer. I'm going to call it student observer. Okay, that's a class. So whoever wants to observe, just implement, just create object out of this observer. Okay, there you go. And then that will be implement observer. Okay, that's the interface observer. That means you have to have the update method. Okay, now I hope you can see the point of our interface. And we can also have some other things just for demonstration purpose, which you don't really need, which is private. So this way you can see what's going on. Static integer observer ID tracker. Okay, so we're going to be 0, private, integer, observer ID. This is for demonstration. Okay, now let me create the student observer constructor, public student observer. That's the constructor. And you just have to say who you're going to observe. So whenever you create an observer object, you have to say who you want to observe. Okay, here is. So you're going to observe a student object, which is this. Okay, so you want to say, I want to observe a student. Okay, all right. So once you have a student, let me just do quickly this observer ID, observer, just for convenience, equals plus plus observer ID tracker. So just add, get a new ID, and sys out. You say something like new observer. So plus observer ID. So you know what ID of each. Now student dot register. See this? The student allowed to register. That's the subject, right? Can register whom? Register this object, this. That's the object you're creating. So whenever you create a new student observer, you will add that to the student's subject, the observable. So you'll be added to the array list, in other words, right? Because this register will add this object, which is the object you're creating, into the register here to the array list. Okay, so that's what's going on. Okay, here you go. So finally, we just need to implement the update method. Okay, that's because we implement an observer. So update. Okay, so update, you can do whatever you want, but I just want to say name, no, name plus colon plus GPA. So we just notify, there's a new GPA value. All right, so that's it. And we can actually do a demo to see how it works, okay? So now we're going to have a demo class. Okay, now demo class, first of all, you have to create a subject. Okay, the subject, we say student. That's what everybody's watching, equals a new student, and then you're going to call this person John, and the GPA is 2.5. Okay, so you have a student. Now I need a bunch of observers to observe the student, right? Okay, so just create a bunch of student observer. Student observer. Okay, student observer. I'm going to call this observer one equals new student observer. Okay, now who I'm going to observe? Student subject. See, that's the this. You're going to observe the student. So whenever you put a new student, you're going to observe this one. Okay, that's how the connections are made. By doing this constructor, you are adding the student you're creating, observer, to watch to the array list of this student's data structure. So it stores there. Okay, so I can have just one, fine. Okay, now watch. I'm going to change the student, the subject that's being watched, observable. That said GPA. See, I'm going to change the GPA now. It's 2.5, right? Made a progress. 2.7. Okay, I'm going to change that. And so run the program. You will see new observer 1 is added, and John now is 2.7. So that observer gets notified. Say, hey, GPA is no longer 2.5, it's actually 2.7. Okay, so now I'm going to add another observer. Okay, so that observer 2. Oh, sorry, observer 2. And that's also watching the same subject. Okay, see, watching the same subject. Okay, now this time I'm going to change GPA for both observers. So the 2 observers, and when the student get a new GPA, both should be notified. Okay, both should be notified. So now when I run it, you will see. That I see. New observer 1 gets added, new observer 2 gets added, and then jump 2.7 doesn't matter for the first observer. This is meant for the second observer. So both gets notified. This is produced by the first observer. This is produced by the second observer. Then that the update matters. Okay, so you could add as many as you like. Okay, 3 and 4, and now you have a change. So all 4 added, and then all 4 will be notified. Okay, it's like you bid on not YouTube, eBay, right? And when people put a price on, bid on an item, right? Then everybody who's watching that item gets notified. Okay, when somebody updated, bid a higher value, then everybody gets notified. So you can see somebody made a bid. All the people watching, because everybody gets notified this way. So whenever there's a new change, everybody notified. So you can decide that I don't want to watch anymore, right? So just say you can say something like unregistered. So you take a student, student unregistered, unregistered. So you want to unregister 03. It's no longer registered. So in this case, if you do set GPA 4.0, a huge improvement. Okay, you will notice that only 3 observers will be notified because 03, this observer is no longer notified because it's not in the rate list anymore. So run this, you will see initially all 4 gets notified. Okay, then observer 3 gets removed. Okay, now only 3 observers gets notified. So you're no longer bidding on that item, then you're not going to be notified. Okay, now on the web, you see, I don't know if you can watch like a stock trading, right? You will watch a particular stock that fluctuates. So whenever there's a new change, people buy or sell, there's a fluctuation of the stock prices. You see that in real time. Everybody sees in the real time. That's another example of observer design pattern. Okay, now everybody can become a observer. All that needs to do, that a class needs to do, is to implement the observer interface and implement that update method. It gives all the flexibility, right? And imagine if you use inheritance. This is going to be a nightmare because you're now limiting yourself to that particular superclass type, like a person type. But this does not have to be a person. It could be anything. Whoever just implements observer interface can be an observer. It has all the freedom. Okay, and no matter how many observers you have, it's just like we used to do the display, right? If you want a new display, no problem. You just add that into the array observable array list. That's all. There's no need to go to change the subject class, right? It's unlike we did I this one. See, if I want to every time I add a new observer, I have to change my original subject class. Now with this new pattern, we don't have to do it. Okay, this is used widely, using JDK, using everything. Okay, the web widely used. When somebody types something, enter something, a lot of observers get notified. Okay, now let's take a look, see what makes this happen. What makes it happen is the interfaces. Because interface, the observer interface, right? The observer interface, make anybody who implement this interface to be such a type, which is a lot more loose than inheritance. Right? Inheritance is so strict, you get everything from the superclass because it's an easy relationship. But this is a has a relationship. Just mean whoever has the observer interface or has the update method can do it. That's all you have to do. You see how much looser this relationship is. So the coupling is less tight, much less tight than inheritance. That gives us a lot more flexibility. So that's why that we have the saying that always favor composition, means it has a than inheritance, which is easy. Easy just too strict, too tight. All right. Now this is we done manually, but because this is so common, so popular, right? So what it turns out is let me do it quickly for your assignments. I just need a couple more minutes. So let's do the API. Okay, the one I just showed you is like our own implementation. So I'm going to do the P3 observer pattern API. Okay, so let me close. Should I close this? Yeah, just close it. Let me do this all over again. So I'm going to write the student class now. Student class is going to be the subject, right? Also known as observable, can be observed, in other words, student. So all you have to do is, this was a design flaw. When they designed this API, that was a design flaw. Okay, so it extends observable. Now, so many people think this was a bad idea because why? This is actually a Java API, and which is a class, not an interface. It was a super class. It's actually a, see, it's getting, now it's going to try to get rid of it now. It was a design flaw initially. Now, watch. You can go back, look at the observable Java API. Okay, you will see that that's 7, right? Even 8, you will see that is a class. Is a class, not an interface. An interface would be better, but is a class. And the class has has all these methods. See, has all these methods. Okay, so that was, that was design. So gradually they are not going to support it anymore. So to use it though, you just have to do the same thing, like a private string name, private double GPA. Okay, now you just do a constructor. Let me do it here, constructor. Okay, and now you don't have to do the data structure, because that's built into the API. Okay, you don't need the data structure. Now we're gonna do the setter and the getter. Okay, setter and getter. And then whenever we do a set GPA, so what we need to do is we have to use a method set changed. Set changed. So that's notify. Okay. Then see, that's always, it was the bad design, so it's gonna cross out. You see that? So notify observers. And you can even pass some actual data there. Say hello. You can pass some, which basically is, you can pass an object if you want. Okay, so so now we just need a get name, set GPA. Okay, that's fine. Okay, so that is the first class, student class, which is the observable. Why? Because we extend observable superclass. Now the only thing left to do is write this observer class, and I'm going to call this student observer as well. Okay. Now this time, student observer does implement observer. That's the proper interface observer, and you can import it. Okay, that's the interface. That's better design. So it's going to get all scratched. Okay, just because the error in here when designing Java use a superclass. Okay, now student has a name, private. We can just say static. Same thing, observer. Observer ID tracker, like we did it before, equals 0, and a private, that is a integer, and then we do another one, private integer observer per ID. Okay. Okay. Now, I also need to have a student, I think. No, I just need a constructor public student observer. Okay, here you bring the observable student, whoever you observe, and then this start a student equals student. You don't even need that. You just say this dot observer ID equals plus observer ID tracker. Observer ID tracker, observer ID tracker, observer ID integer. Did I spell wrong? Observer ID tracker. Lowercase, I'm sorry. So we track that, and then we just say sys out, say the same thing, like a new observer colon this dot observer ID. Okay, now we just add observer. Student dot add observer. See, that's the API method. Is equivalent to our register. The data structure you don't have to do, it's already included. And then say this. Okay, so that's the one. And then we going to just say update because we have to have the update method. Add the method that's update. Okay, and this object is the object we put inside here. We said hello. Remember that? That's the object. So whatever object you pass here gets received here. Let me close all of this. It's good. That's the object that holds the hello. Okay, now we say this out. We say we need have a cast student and student and dot get name plus then put a colon student the cast it basically that's a student GPA. Okay, so I need to put semicolon. Student is the O, is the observer. So just put the O there because that's the observable. Or I can just put a student over there. Get GPA, I don't need this. That's not 0, it's O. Pass this, that's O, get a GPA. Did I write wrong? Get GPA. Observer get a GPA. That's correct. Why? It's around the cast. Oh, yeah, here. And I get it too many. Okay, so that is the update. Now, if you do want that hello, you could do that as well. Then just say ARG. That's the hello object. Okay. All right, now we can do a demo. Just the demo and main, and then we can just add, create a bunch of us. Okay, just here. So student as equals new student, just like before. So that is A, that's the name, and 2.5, that's original GPA. Okay, so now we're gonna say student observer, student observer 01, that's the first observer, student observer y1 equals new student observer, and you can also observe S. Okay, so you have this, then that's the same really. So you have a student two observers. Now we're going to change the GPA. So S dot set GPA. Okay, so it's a 2.7. There's a progress. Okay. And we can run it. Then both observer added, and then 2.7 for one observer, 2.7 for the second observer. Okay, and if you want to, you can delete the observer if you don't need one, and you can add. Okay, so if you want to delete one, you can just say, let me say s dot delete observer, and then you put it down whoever one you want to observe 01, or delete that one. And once you've done that, s dot set a GPA. So now only one person, the second observer, will get that 4.0. So initially, both observer gets 2.7, but only one observer gets 4.0. Okay, so because of the design flaw, people realized, so this is whole going obsolete. So now you could use the new implementation. We don't have time to talk about, but you could also write your own subject. Okay, write your own class like we did before. Initially, so it wasn't that hard. Okay, so again, it shows the importance of interface. Okay, so we're a little bit late, and I'm gonna give you some assignment, so you can use the model view controller and observer design pattern to implement some application using Scene Builder and have different views. All right, so I will send you a notification through Piazza and tell you my availability, okay, either towards the end of this week or early next week. You take a look at it whenever you're available, let me know. And I think mostly we should be okay. We don't have that many students, and I'm pretty flexible. And then this way we can take a look at your program. All right, just make sure you load your program before the meeting. And so I load yours as well. And then so we can go through them together. Okay. All right. So see you next week, actually. You have a wonderful Thanksgiving. Okay.
You too, Professor.
Have a good Thanksgiving.
Thank you,
Great.
Professor.
See you
Have a
guys.
good Thanksgiving.
Have a good holiday.
Bye.